Number 9, 4 functions are described below. Each function is accompanied by an integral involving that function. For each integral, give units for the integral and explain what information it gives you. I'll go ahead and put a general thing up here at the top. For each of these problems, we're going to use something called the fundamental theorem of calculus, which says the following. If you integrate a derivative between a and b, then you're going to find the actual change in the function between a and b. Integrating the derivative gives the actual change in the function. Okay, part A. The function v of t gives upward velocity in kilometers per second of a rocket t seconds after it was launched. Interpret the integral from 0 to 120 of v of t dt. Okay, so before we do, let's think about units. Units for an integral are always the units of v times units of t, whatever those letters are multiplied together. So the units of v, I guess I'll just write that, v units times t units. So v units was kilometers per second times t units is seconds. So the ultimate unit for that whole integral is going to be kilometers. So now we have to somehow relate the fundamental theorem of calculus to this question. Fundamental theorem starts with the derivative. V is the derivative of some function. It's the derivative of the position function. So if you integrate the derivative of position, you'll get change in position. So this integral right here represents the change in position. Of the rocket between t equals 0 and t equals 120 seconds. Alternatively, you could probably get away with saying that integral represents the distance the rocket travels during the first 2 minutes. I guess technically the integral is the displacement of the rocket, just in case the rocket goes backwards. It's not going to give the distance, it will give the displacement. Part B, the function a of t gives the rate in thousands of antibodies per minute, at which antibodies are produced t minutes after a foreign substance is introduced into the blood. Interpret this thing. Again, we'll look for the units. So the a units are in thousands of antibodies per minute. Times the t units, which are minutes. Those cancel, and the units altogether are thousands of antibodies. And so this integral right here will represent the number of antibodies introduced in the first 4 minutes. After the foreign substance was introduced. I guess I'll put here that antibodies numbers in thousands. Part C, the function r of t gives the rate in millions of dollars per year at which a country's debt was increasing in the year t. Interpret the integral from 1980 to 1990 of r of t dt. Again, we'll start with some units. R units is millions of dollars per year times t units, years. And so the ultimate answer is going to be in millions of dollars. So this integral represents the change in this country's debt, actual change in this country's debt. In millions of dollars between 1980 and 1990. Finally, most complicated one, the function f of t gives in dollars per day per degree the change in the daily cost of heating the east building if the average daily temperature increases from t degrees Fahrenheit to t plus 1 degrees Fahrenheit. Interpret the integral from 30 to 40 of f of t dt. Okay, to simplify this, again, we want to think about units first. The f units are given, it's complicated, dollars per day per degree times t units. T is measured in temperature, which is degrees. And again, we cancel, and we get $1 per day. So somehow, This integral is going to give us some answer in the unit dollars per day. Okay, so what's going on here? We are finding the actual change in cost for heating the east building for a day. So this is going to be in dollars per day. When the temperature goes from 30 degrees to 40 degrees.